Okay, in question one, I've gotten some feedback, and the thing that I heard from students was they want to make sure I'm very clear about what base we're in and what base we're going to. So I will spell out the things that I've highlighted in yellow here. In the first instance, that's a base 2 number, and I want it converted to base 10. The next one's a hexadecimal or base 16 number. I want it converted to base 10. And the third one's a base 10 number, 158's base 10, and I want that converted into binary. So before we jump into the specific questions, let's just talk a little bit about different bases and number systems, right? The one that we're most familiar with is called base 10 because if you look at it, all the place values in this base 10 number system have a base of 10. In fact, when we write something, when we write a number down, right, like 325, if you take a look at it, there's place values here, right? This first thing is 5 of these 10 to the 0 powers, or we just call them units, right? This is 5 1. So you can write 5, you can write that's 5 times 10 to the 0 power, which is just 5 times 1, which is just 5, right? So I've got a 5. This next place is, look at it, it's the tens, right? So I've got 2 times these 10 to the first power, 2 times 10, which is 20, right? So the value of that 2, its location and the number are both significant. They both make up its value. Its location is in the spot where tens are, and how many of those tens do I have? I've got 2 of them, so that's 20. And then this third one, right, this is the spot where we store our 10 to the second power, right? So I've got 3 of these 10 to the second powers, or 10 times or 3 times 100, right? So this is 300. That's why when we look at a base 10 number, it just rolls off the tongue, right? It's 3 of the hundreds and 20 and 5, right? 325. 3 hundreds, 2 tens, and 5 ones. Now, this same idea extends to other base number systems. The two that we use often in computer science are base 2 or binary, and we also use hexadecimal or base 16. And the first question that we have here says, please write this number 011011 into base 10. So it's a base 2 number system. We need to write it in base 10. Well, let's take a look at base 2. In the base 10 number system, right, we need 10 different characters to make this work. And the characters we use are 0, 1, 2, 3, 4, 5, and 6. And those make this work perfectly. Except there's not enough. We need the 7 and the 8 and the 9. So if you look at it, there are 10 characters there, and that's perfect, right? And this having a 0 is brilliant too, because it allows us to indicate that we've got nothing of a particular number. So we need 10 characters in a base 10 number system. In a base 2 number system or binary number system, we only need 2 characters. And the characters that we use are 0 and 1. In fact, this 0 and 1, it gives us kind of the icon that we use to represent either on or off. 1 being on, 0 being off. Now that's something that works well with base 2 because each one of these place values are either on or off. We don't have, it's not possible to have multiples of any of these one places. You either have that one or you don't have it. And you'll see how that works in a moment. So let's take a look at a number like it was 0, 0, 1, 1, 0, 1, 1. What number is that? Well, what it's telling us is that the 32s, we have none of that, right? That one's turned off. But the 16s, because this is a 1, this will be turned on, right? Because this is a 1, we have an 8. We don't have anything from the 4's place, right? We do have something in the 2's place that's turned on, and the units place is turned on. So if the question is, what is this in base 10? It's simple. It is 16 plus 8 plus 2 plus 1. Or what is that? 20 plus 1, I said. Should write it. That's 24 plus 3, or the number 27. So when I write 011011 in base 2, that's equivalent to 27, right? They're both holding the same value, they're just holding it with different schemes. One's base 2 or binary, and the other one's base 10. The conveniences of base 2 we've discussed, and I think I've shown some of you before. It's very easy to do arithmetic in base 2, and it's super simple to teach computers how to do arithmetic in base 2. So that's one of the questions. I'm giving you a number. Tell me what that is in base 10. The other question I gave you, and let's skip to that. It was part C. It says, what is 158? It's base 10. Convert it to binary. Convert it to base 2. So let's come over and take a look at that. So we're looking at 158. Now, what I typically do is I start with the largest possible number that I can. And you can see 256 is too big, but 128 is perfect, right? So I've got 128 by turning on that place value. So in my answer, everything I highlight in yellow is going to be a 1, and the things that I don't highlight will be zeros. They will be turned off. So what do I have when I do that subtraction? And by that I mean, look, I've got the 100, whoops, not the highlighter. I've got the 158, and I'm going to subtract 128 from it. Well, when I do that, I'm left with exactly 30. Well, I need to now build the number 30 from the remaining digits, right? 64 is too large, 32 is too large, but I need a 16, right? So I'm going to grab this and I'm going to turn on this spot. This is now on. So what do I have now? Well, let's take the 30 and subtract 16. 30 minus 16 gives me, what is it, 14? Okay, so I now need to build the number 14. Well, 8 is not too big, so I'm going to turn the 8 on, right? Let's continue, right? 14, and I'm going to take away an 8. 14 minus 8 yields 6. So I need to build the number 6, and I can see in order to finish this off and build the 6, the 4's spot needs to be on, or 2 squareds, and the 2 spots needs to be turned on. Everything else is going to be left off. So if I was to write this number out in binary, you can see I've got a 128, no 64s, no 32s, I've got a 16, an 8, a 4, a 2, and no units. So that means that the number 158 written in binary, probably we would group it more like this, would be 1, 1, 0, 0, 1, 1, 1, 1, 0. And you usually see these written kind of like that in slight groupings of 4, right? So 1, 0, 0, 1, 1, 1, 1, 0. That number in base 2 is equivalent to 158 in base 10. They're the same number, just different schemes. The final number we have here is 3A2. That's written in hex, base 16, and you're asked to convert it to base 10. So let's talk about hexadecimal. What's that look like? What does it look like when we're talking about things that are in base 16? Well, in base 16 numbers, just like in base 2 and just like in base 10, right, our bases are that number. So I've got 16 to the 0 power, 16 to the first, 16 to the second, 16 to the third, 16 to the fourth. So I know the value of each place in this number system, right? If I have things that are written in this particular decimal place, every single value there is worth 256. Now, in base 2, we needed 2 symbols. In base 10, we needed, and the 2 symbols in base 2 were 0 and 1. In base 10, we need 10 symbols. We use the digits 0 through 9. In base 16, we need 16 digits. And we only have our 0 through 9 available to us, so what we do is we assign the following letters to continue on. So this is 10, 8, 11, 12, 13, 14, and 15. So I'll write their values up here. So A is equivalent to 10 units, B is 11 units, C is 12 units, this is 13, this is 14, and this is 15 units. Which is kind of what we expect because we saw it in base 10, right? The last spot in a base 10 number system is a 9. And if I want to go past that, right, I roll over, put the 0 there, and I carry. So that's what happens here. So how in the world do I interpret what numbers are in this system? Well, it's just like we do it in our system. And I say our system, they're all our systems, but I should say the one that we're most familiar with. So let's look at this number that we have in base 16. We're given 3a2. Okay, so I'm going to write these right below each of these. I've got a 3 and an a and a 2. So what does that mean? Well, I have to start with, I have 2 times 16, not 10, 2 times 16 to the 0 power. 2 times 16 to the 0 power is 2 times 1, or I just have 2. So part of my answer is 2 is involved, right? The next thing over is I've got some of these characters, and I wrote an 8 there. That's supposed to be an A. Sorry. I've got this many things in the 16th place. Well, how many are that? Well, that's A, right? I've got A of them, which is equivalent to 10. So what do? I'm going to write, I've got 10 of these 16 to the first power, or 10 times 16. This is 160, and this is also part of my base 10 solution, right? The two of them added together give me 162. In fact, the number A2 is equivalent to 162 in base 10. So the last thing I need here to build the number is, let's see, I've got 3, not 300s like it was a base 10 number system. I've got 3 of these 16 squareds, right? In base 10 it would be 10 squares, and those would be 300s, but in here it's 3 of the 256s. That's a large number. It ends up being 768, and that's part of my answer. So my answer here is the sum of those 3 values, and I get that those 3 values together add up to 930. So this, right, 930, this is the base 10. That's the same as 3a2 in hexadecimal. And you could take the 930 and you could convert that to base 2 as well, but we'll just leave it here. So 3a2 in hex is equivalent to 930. Perhaps you might want to practice a couple more of those, so I'm going to give you 2 and then I'll show you the answers. So there's 2 different numbers that are written in hexadecimal, and the question is, what are those in base 10? You might want to take a look at this chart and spend a little bit of time thinking about it, but I'm going to ask you to pause right now and then I'll show you the answer. So hit pause. So there's your answers, right? In base 10, D21 is 3,361, and in base 10, 31C is 796.